A disc of radius 2 meter and mass 100 kg rolls on a horizontal floor. Its center of mass has a speed of 20 centimeter per second. How much work is needed to stop it? How much work is needed to stop it? The required work is, so first of all, radius given, radius is 2 meter and mass is 100 kg and velocity equal to 20 centimeter per second, that is nothing but 20 into 10 power minus 2 meter per second. Yes, so that is the data given, that is the data. Now required work equal to change of kinetic energy, change in kinetic energy. So it's going to reduce, right? How much work is needed to stop? Negative work done is going. So then if you do it, double equal to Ki. So kinetic energy initial. So kinetic energy initial formula is half moment of inertia omega square plus of mv square. So if you substitute the data, so kinetic energy initial equal to half into moment of inertia, we can also write like this, and angular speed can be written v by r, that is nothing but v square by r plus of mv square will be the same. Then here, so we can see square will be there. Here square square get cancel, rr get cancel, here rr get cancel, and 1 by 2 into 1 by 2, 1 by 4 mv square. So we'll get 3 by 4 mv square, 3 by 4 mv square. If you substitute the data, 3 by 4 m is nothing but 100, velocity is nothing but 20 into 10 power 2 whole square. If you do this, we'll get 3 joule. So that is the kinetic energy initial. So here answer is B, 3 joule. This is the answer. So if you like this content, do like, share and subscribe to Student the Brand. Thank you.